Okay, we are going to be looking at an exponential function, and what we're going to be doing is developing the concept through an interactive tool. Therefore, when I ask a question, I want you to put it on pause as you answer the question for yourself. Write your answers down, and I will be working it through with students that I have right here with me as they interact with us as well. So let's see how this goes, and let's have fun as we develop this. So first of all, we are going to look at this from the idea of a sequence. And so the first thing I'm going to do is write a sequence up here. So I'm write 1, 2, 4, 8, 16, and remember this continues on. What is the pattern that you see in this sequence up here? What?
It doubles.
It doubles every time. So if I were to write this as an equation, how would I write it?
It's going to be 8 minus 3.
4 divided by 2.
4 divided by 2? What would that give you, Dessa? It would give you 2. Okay, but does that build me an equation that's for anything I want to use? It's a good start,
You need
though.
the a sub 1 times n minus 1. No.
It's making sense?
A sub
I have
1
one left over.
equals,
I can't remember the formula.
that's okay. Well, let's think about it. What happened here? If I were to say something is being taken to a power, what would it be? You started it right, Dessa, when you said divide here. What does this tell me?
Oh, I'm still stuck on trying to figure out the formula.
It's okay. What does it tell you?
It tells you that you need to take it to the second power.
Okay. So what if I took another number and took it to the second power? Would that equal 4?
No.
So is it the power that is the number 2?
Oh, so then it's going to be 1 minus n is the power. It's going to be like 2 times 1 minus n.
Are you sure?
I'm pretty sure.
Well, let's see. If my number of my term was 3, 1 minus 3 would be
Okay.
negative, wouldn't it?
Yes.
So what should we do with that?
Flip
instead?
them.
Flip it, yes. So that will be n minus 1, right?
Yes.
Okay, now, what has to be in here, taking it to that power?
The distance. It would be,
Is it the distance?
no,
or
it would
is
be or.
It would be a to the n minus 1.
A to the n minus
Okay,
1.
yeah.
Okay, now that is when we're talking about a sequence, right? What if we were to change this into a function that is exponential? What would the differences here be? So instead of saying a sub 1 or a sub n, what would that become? How do we designate a function?
F of x.
F of x is one possibility. In other words, a function at the value that we put in for x, right? And what is that going to be equal to? If we're talking exponential. What is our a in the case of this sequence we build up here?
1.
Would it be 1? 1 to the first power? 1 to the
No.
second
They
power?
would, okay, it would be 2.
2. It would be 2, and that would be the base, right?
Yes.
And so 2 to what power now? Where is our variable going to go? Do we have a variable over here yet?
No.
No. So where's that variable going to go?
It's going to go in the exponent.
Okay, so where is it, Dessa? Right up here, right? So now we actually have developed completely an exponential function. What would this exponential function look like as we graph it? So let's look at it.
A straight line.
You think so?
No.
Remember, we're gonna have an XY coordinate plane here. And we're going to have to put a little bunch of little lines on here, hash marks, for this thing.
Sometimes. I don't know why the program does that, but sometimes they don't even explain why.
Okay,
Well,
how do we know how to graph something like this?
well, you could always change f of x with y.
Okay, but we want to keep it in function format, but yes, you
Pick
were
a
right.
T-chart.
It's the same thing as y equals 2 to the x. It produces the same kind of thing, yes.
And then you can add, put 0 in for,
I can put
Each one.
numbers in for the x.
and for the y.
T-chart.
T-chart, yes, a real handy T-chart.
Did you forget your
So,
T-chart?
let's go ahead and do
No,
that.
I hate the t-shirt.
Oh, do you?
Okay, so what number do you want to start with here?
-1.
Shall we go one more smaller than that? So we have a few more? Yeah, -4 is good. Yeah, that would work. Okay. What if we put -4 in for x? What's gonna happen? Equals 2 to the -2.
They have to be on the top.
What happens with a negative exponent? What does that do to your base?
Well, since it's an even, you're still gonna have a positive.
We probably didn't grab all
Does a
the-
negative exponent actually change the sign
No,
of your base?
it doesn't.
What does it do?
You flip it over.
It's the reciprocal, you're right. So we're going to flip this over. So f of -4 is equal to what? 1 over 2 to the 4th power, which is what? 1/16? So that's your first one. What's the second number you want to use?
Class 2.
0.
Depending on how
High
much.
five.
You want to do 0? Now let's do -1 instead, and then we'll go to 0, okay?
Okay.
See your.
Didn't I grab my eraser?
No.
Grab one from over here.
Let's say you did not right here. You want to-
Okay,
Right, you would have to include 4x
so let's do that one.
and
So my f of -1 is equal to,
4, 3, whatever. If
what's
it
that
was
one going
supposed
to be?
Just those two. Okay. But
1/2.
if it was just here, because it's
1/2.
4, it's 2, 4, it's 1. Okay?
Okay, now let's go to that 0 we were talking about.
So.
It's gonna be 1.
Yes.
Really, it's just right
Anything
there.
to the 0th power is always 1.
Always 1. Excellent recall. Good job, guys.
I'm good
Okay,
with that now.
so let's go to the next number.
Really simple.
2.
Okay.
They just want to know the location. They don't really want to have the whole electron thing. They're not after that.
What's that?
Pull it up so you
4.
don't have to do that.
Okay. Shall we plot these on that graph now? You guys are doing okay. Just keep talking. That's all I need. -4 and 1/16. Where's that gonna be? Right here. Really, really close to that axis, right? The next one.
It's gonna be
Okay.
Yes.
You're gonna go 0, 1, and then you're gonna go 4.
And we did 2, 4.
4A.
Okay. Now, if we graph that thing, what's it gonna look like?
Look what I got right here.
So you're gonna have to include
It goes
two
up
raised
rapidly
to,
on the
and then
right-hand
2p,
side. And where does it go to over here?
And 2p,
Right, where do you
One.
get?
It approaches the x-axis, but doesn't cross it.
It approaches the x-axis but doesn't cross it.
So the x-axis of 0 would actually be the horizontal
where it looks
axis.
is 1.
Yes, the x-axis at y equals 0 would be a horizontal asymptote. What does that tell us then about the domain of this function?
It'll be 0 to infinity. Or no, infinity to infinity.
Yes.
And the
The
range would
domain,
be,
because that's your x value, right?
yeah,
It is negative infinity to infinity.
and
How
then the
about the
range is
range?
0 to infinity.
The range is 0 to infinity. Okay, let's talk about a few other things, about some parameters on this.
You probably know if I heard.
Are we ever going to have this base here be less than 0?
I don't remember how much we were.
Why not? What would happen if my base was less than 0?
Just flip it over.
Not if I had my negative 2 inside. What would
Oh,
happen?
no, but you didn't say anything about parentheses.
Yeah, but when I talk a base, isn't that mean the whole thing is inside the parentheses because it's the base, not
Well, not
in front?
necessarily, not according to math.
Well, that would be a coefficient in front, okay? But you are right, a coefficient in front would flip it over, Dessa, you're absolutely right. But when we're talking the base being negative, what's that gonna do with that there? Well, at 0 it'll be 1, but at 1, what's my answer going to be? How about a negative 2?
Some of them are, yeah.
And at 2, it's gonna be 4. At 3, it's gonna go
It's not
down.
gonna pass the vertical line test.
Well, it would pass the vertical line test, but what it's gonna do is it's gonna bounce back and forth. Like this. And it's gonna do the same thing on this side. It's gonna bounce back and forth like this. Which doesn't make a very good function if we're talking a smooth, continuous, in one direction motion. So that puts some parameters on us. Our base, which we often call A in this case, but I'm just gonna say the base. What does the base have to be? The base has to be positive, which means it's greater than 0. There's some other interesting things about that base. What happens if the base is 1? Could my base equal
It cannot equal
1?
1.
What kind of function would that create if it was equal to 1?
Straight line.
A straight line, yes. Through what? That point right there, right? Because anything to the first power, just 1 to the whatever power is always 1. So everything you put in would be 1. All right? So that means our base cannot equal 1.
But it can equal a half, or
It can equal a half. So what is true if my base is greater than, no, if my base is greater than 0 and less than 1? What's true about that line? Is it going to be this way?
No, it's, instead of it increasing, it's gonna be a decreasing function.
It's going to be a decreasing. It's going to go the opposite direction of what the other one was. And it cannot equal 1, but it can be greater than 1. Or like I wrote up there, I'm gonna write the other way. It'd be easier to see it. Base can be greater than 1. So there are some limitations as to what the base can be, right? Okay, now, do you have any questions about this exponential function?
The one that you had a question about.
I don't.
Dessa?
Why would that one be different?
No, it's okay. If you understood it well enough that you don't have questions, then maybe we need to practice a bit and then see what questions come up as we actually do some work, okay? Okay, thank you. I hope you enjoyed this and go get busy practicing. Turn it off, Wes.